Alright, so for your second lab assignment, we're mostly working here with binomial distributions and normal distributions. So again, just to give you a really quick overview, hopefully to show you that it's not as intimidating as it sounds. Basically, I'm going to make numbers up, but it's going to be very similar to what you're going to use in your lab. So at any rate, what I'm going to do is we're going to have trials, and you can label that whatever you want. So I'm going to do 0 through 10. And then in the second column, I want the probability that x is equal to x. In other words, I want the probability that x is equal to 0, or the probability that x is equal to 6. So for this example, we're going to say that a success is 23%, which is your p-hat, which means that q then would be 77, but I don't need that value for this. When I look here at the values, if I just want to know exactly what they are, then, and we're going to do binomials first, then what I do is I go over here to more functions. Under statistical, I'm going to choose the binomial distribution. So the number refers to what probability are you looking at. Are you looking at the probability of it being equal to 2 out of 10 trials? Or are you looking at the probability of it being 0 out of 10 trials? So because I need this probability distribution table, and I'm going to start at 0, what I'm going to do is I'm going to highlight this column where the 0 is at, so that when I copy the formula all the way down, it'll copy A10 or A11. I have 10 trials. We said the probability of success was 0.23 or 23%. And cumulative means, are you adding the probabilities as you go? So if I want the probability of x being less than 4, then I would be adding the probabilities of 0, 1, 2, and 3. In this case, I am not adding probabilities. I don't want them to be cumulative. So we're going to type in false and hit OK. And then if you toggle your cursor until you get this little cross over this black box in the bottom, and you drag that thing down, it's going to copy that formula all the way down. Notice that for mine, that's basically a 0, right? Because that would be moving the decimal place to the left 5 places and putting zeros in all those spots. So it's not a bad probability. When you think of probabilities, they have to be less than 1, right? And you might look at that and think it's 1.39. Well, actually, you would take that e to the negative 5 and move your decimal place 5 places to the left. So we would actually have 4 zeros in front of the 139. So that's a very small probability. So now, if you wanted to find out the probability that x is equal to 7, you would just look in your table and see that it's 0.001865. Moving the decimal place, that's 0.18%. So highly unusual event there. If I want something like the probability that x is greater than 6, then I'm looking at adding probabilities together. It's greater than 6, so we're not going to include the 6. And actually, you can use your Excel feature here. When you hit equals first, that tells the system that you're going to put a formula in, and I'm going to tell it to sum everything below 6. And then I get my probability. Again, very small, 0.21%. If there's an equals, so if I want the probability that x is less than or equal to 2, well, now you're saying that you wanted to add the probability of 0, 1, and 2 because there's an equal in there. So you can do equals the sum and then have it add those 3 together, and then you would get that probability. So this is for the binomial. For the normal distribution, again, the same thing holds true for the false and true idea. So let's just do an example where our mean, and I'm going to use mu because I can't actually draw the signal for mu, where the mean is like 10.4, and then we're going to have a standard deviation of 1.2. Okay, so if I want the probability that x is less than 4.5, and we're assuming, again, this is a problem with normal distribution. I guess I could put that up here at the top for you. So now I'm actually going to add the probabilities in a normal table all the way from 0 to 4.5. So because I'm adding them, when I go through here, and again I'm going to choose more functions, statistical, but now we're going to scroll down until we see the normal distribution button. So I hit enter, and then it's going to ask me what it wants for these values. Well, in this case, my x is 4.5. My mean is 10.4. My standard deviation is 1.2. And now it's asking again, is this cumulative? And this is cumulative up to that number. It's not including the 4.5. So that's why the x is 4.5. So here we're going to put true. And we get a very small probability. If I have something where you're going to be subtracting probabilities, so maybe the probability that x is between, let's just do 7 and 8. Oh, 9 is fine too. So I want the probability that my value is going to land between 7 and 9. Then what do we end up with here? Well, actually, let's make that a little bit bigger. Let's go like 12. Okay, so if you were to draw out on a normal curve what this would look like, realize that your mean is in between there. So you're actually going an area under the curve where we're going to look at going all the way to 12, and then subtracting the area up to 7, so that I actually have this middle section between 7 and 12. So you're looking at taking the probability of x being less than 12, and you need to subtract off the probability that x is less than 7, because you're actually doubling up here, right? When I do between 7 and 12, if I do all the way to 12, I'm going from 0 to 12, and then here I'm going from 0 to 7. So 0 to 7 is actually doubled up. So what we do is we're going to do the normal distribution. So I'm going to find the probability, the area under the curve up to 12. That's what I'm finding right now. And again, this is going to be true because I want the area up to 12. Okay? And then we're going to find the area up to 7. And because when we go up to 7, it doesn't include the 7, that's why we can do it here. And then realize that the 7 was included with the x being less than 12. And then we just want to subtract those numbers. So you can just pick a box and say that I want the probability that x is less than 12 minus the probability that x is less than 7. And then I get the value that I want. A very big part of finding these probabilities is drawing out that curve, figuring out the shaded region, because sometimes, you know, for the probabilities that are greater than, you're going to be to the far right, and so your distributions go from left up to the number. So if I'm on the right side of that number, then I have to do a 1 minus, because remember that the entire area under the curve is equal to 1.